All right, so this table gives a list of heart rates basically for an athlete running a 100-meter race. The race lasts 10 seconds. And so this is the time in seconds. This is the heart rate after that match time. And basically it's asking us, does this function model the data in the table exactly? And then does P provide a reasonable model for the athlete's heart rate? And then does P of 12 have significance in this situation? And then what should the domain be? All right, so in this case, what we have is for the first one, we have to figure out does, this input give us this output for this equation. And so what we're going to do is I'm going to cheat, go to use a calculator. And so if we plug in, say, let's do the 4. So we're going to have a zero point 0.3 times, and we have a 4 squared, and then we have plus, and then we have 3 times 4 plus 87, and that's supposed to be 104. And it gives us 103.8. Close, but not exact. And that's the key question they're asking here. So let's plug in another one. So instead of 4, let's do 8. And let's do 8 here as well. That's 130.2, and an 8 is supposed to be 130. So I think what we can say is no. So for A, it's no, and it gives an approximate value that is close to the actual. Okay, so again, this one we had, 130.2, and this was, which one we do, 103.8. So that's not exact. Okay, so now for B, does it provide a reasonable model for the athlete's heart rate? Yes, I'll agree to that one. And for the same reason, because on A, I said it gives us an approximate value, but it doesn't give us exact, so it does give us a reasonable model. Now, C, does it have significance in a solution? Well, no, because the race only lasts 10 seconds, and so after 10 seconds, they're not worried about anything. They're not keeping track of it or anything like that. So it's not significant here. And because the domain in this case is what was from 0 to 10, and 12 is outside of that domain, and so it really has no effect on what we're looking at here. So that's why it doesn't have a significance in this situation, because it's outside of our actual domain of our table. All right, so here we have one, and it says, what is or it says the grade of a hill is measured in of the steepness, and basically corresponds to your slope of the highway. So, you have some kind of a hill and however steep it is. Now, the braking distance D in feet for a car traveling 60 miles an hour on a wet uphill grade is given by this expression. So we're going to go this way uphill, and we're going to put on our brakes, and whenever we start the brakes to the time we actually stop, that's going to be the braking distance. And it's given by this function. All right. Now what we need to do is it doesn't actually show it here because I forgot to copy those pieces of the thing, but it wants to know what is, oh, where's my pin? There it is, D at 0.13. So when the steepness or the grade is a 13% grade, what is our value? Well, so what we're going to have to do is we're going to take 3,600 divided by 30 times 0.13 plus 9, and we plug that into our calculator, and I've already calculated this out because it's going to take a long time to go back and forth and back and forth, and so that's going to be approximately 279 feet. Okay, and that's what they want it to round it to the whole foot. It doesn't want the decimals, it just wants the whole foot. Okay, so that was part A, what they were wanting. Part B, what they're asking for is uh, if the braking distance is 350 feet, what is our grade over hill? So if the distance is 350, we're going to say, well, 350 equals 3,600 divided by 30x plus 9. Well, now we have to solve for x, so if we multiply both sides by 30x plus 9, this cancels here, and so we basically have 350 times 30x plus 9, and that's equal to 3600. And so now we take the 350 times the 30, and that's going to give us the 10,500 x plus, and then we take the 350 times our 9, and that gives us 3150, and that's equal to 3600. So we'll subtract 3150. And so 0, that's 5. That's going to be a 4, and that's equal to 10,500x. Now, if I divide that out, so then that will be, let's see here, we're going to get, it looks like a zero point 0.4. So x is going to be 0. Actually 0.04, I should say. 0.04. Okay, so if we convert that to a percent, that's going to be about a 4% grade. Okay. So that's going to be how steep it is. And so it's kind of like some of the hills around here in Wyoming are not too steep, so that would be kind of a smaller grade hill here. And again, this is going uphill. When you're going downhill, it's going to take a lot longer if we wanted to do that one. So that one will be actually a longer version. If we went downhill, that's going to take longer to stop on a wet than it will going uphill. All right, let's stop there and we'll come back for some more.